flip geometry. Here we are again. We're going to do 4-4 and 4-5 today. We're going to do 2 lessons. I'm not sure how long this video is going to be, but it's going to be pretty lengthy. But we're going to get right into it. We're talking about how to prove triangles congruent, and when we're done, you will be able to use different postulates. We'll get to what those are in a second. You'll be able to use different postulates to test for triangle congruence. So in the last lesson, we talked about how we needed 3 sides and 3 sides and 3 angles from one triangle congruent to 3 sides and 3 angles from another triangle in order to say that they were congruent. So we needed a total of 6 pieces, right? And then at the end we could say, hey, 2 triangles are congruent. We can write a congruent statement. For these two, it would have been ABC is congruent to triangle HJK. But now I'm telling you that we don't need 3 sides and 3 angles. We can take some shortcuts, and we're going to be looking at those shortcuts today. The first shortcut we're going to take a look at is the side congruent shortcut, and that says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Basically, if all you know is that 3 sides of one are congruent to 3 sides of another, you can automatically say then the 2 triangles are congruent to each other. So next we're going to write a flow proof. Basically what a flow proof is, it's a flow chart that flows in a direction where you're trying to prove something given some constants. So it's better just to show you instead of to explain to you what it is. It might just confuse you. So let's just start with this example here. You're given that QU is congruent to AD and QD is congruent to AU. Using that information that you have there and then the diagram itself, you need to prove that QUD is congruent to ADU. So here we have our flow chart, and what you see is a couple of different ovals, bubbles, let's just call them bubbles, and the 3 of them are connected to one main bubble here. What's going to go in that last bubble is what we're trying to prove, and if you remember, what we're trying to prove is that triangle QUD is congruent to triangle ADU. But now we need to fill in what's on the left hand side of the flow chart, and we can start with what was given to us. The information that was given to us was that QU was congruent to AD. Right under that bubble, you want to put the reason. What makes that statement true? And the reason for that is just that it was given. So you're just going to write it right under it. Okay, the next given was that QD is congruent to AU. That was also given to us. Now, our third one is something that we need to come up with ourselves by looking at this figure. And we need to figure out how, with the information that's given to us, how this is going to be true here at the end. Now, the only thing that we've talked about is side congruence. So that's the only one we have now. So let's look. We've got QD and AU congruent to each other. We've got DA or AD congruent to these two. Which one is going to make it available? Which one is going to make it right for us to say that these 2 triangles are congruent? So this last side, DU, which I'm going to mark, is congruent to itself. I'm going to write that in there. DU is congruent to itself. Why? We talked about this in the last lesson. The reason for that is called the reflexive property. Anything is congruent to itself. We could just write reflexive property. So given these three things, we have, and I'm just going to circle, one side, two sides, three sides. We can now say that these two triangles over here are congruent because of side, side, side theorem. At the end, I'm going to erase what you don't need. You don't need to circle anything. All you really need, and you don't need to highlight anything, all you really need is the three reason, the information inside of the bubbles and the reason for it right under it. We're going to do about 3 more of these, so just to make sure that you guys understand what's going on. The next congruent shortcut we're talking about is side angle side, or SAS. And that basically said is if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. Now, let's take a look at this figure here. These two sides, the included angle, I just want to highlight that word there. Included angle just means that if you have two sides, it's the angle that's between the two of them. Okay? If you have two sides that are congruent to two sides of another triangle, and the included angle, that means that the triangles are congruent. So here we have side AB congruent to DE over here. That's one side. The other side is BC to EF. And the included angle is B and E. Since we have SAS, we can say that ABC, triangle ABC, is congruent to DEF. So now we're going to try our second proof. The given statements are that C is the midpoint of DB and that ACB is congruent to ACD. And we need to prove that two triangles, ABC, is congruent to ADC. So let's go ahead and jump into our proof. Now, again, let's start with our given statements. The first given was that C, I'm just going to use some shorthand, C is the midpoint of DB. And again, that was our given. Okay, but what does that do to our figure? Let's go ahead and mark our figure. If C is the midpoint, that means that this is congruent to this side here. So I can say that in the next circle, in the next bubble, that DC is congruent to CB. And what's our reason for that? We can just put midpoint theorem. That's what the midpoint theorem tells us. Midpoint, and I'm just using shorthand, theorem. Now our other given was that ADC, angle ADC, was congruent to ADB. And that was also a given. And I'm going to mark that also on our figure here. ADC, which is this one here. Now we need to find our third one, because now if you look, we have a pair of sides. I'm just going to mark that here. We're looking for SAS. That's what we just talked about, side angle side. We've got one side here. That's a pair of sides. We've got an angle here. So now we've got to find another side here to make it work. To make this, remember, what we're trying to prove, and I should have put this at the beginning, was that triangle ABC was congruent to triangle ADC. And the one we're looking for is SAS. Most of the time you won't know which reason you're looking for. Sorry, I should have written that in red, just to keep it the same. So we've got S, we've got A, we need another pair of sides. Remember, this has to be the included angle. So if you look at our figure, the one that's left is AC congruent to itself. AC is congruent to itself, using again the reflexive property. Now we've got a pair of sides. We've got a pair of sides here and here, and the included angle, SAS, to finish off our proof. Again, I'm just going to erase the stuff that you don't need. All you need is what's inside of the bubbles and the reasons for it right under the bubbles. Our third shortcut is called the angle side angle congruent shortcut, or ASA. And it says if two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So again, we've got that included word, but this time we're talking about an included side. We've got two angles and the included side, this side here. The same way here, we've got this included side between two angles. And if we have that, two angles and the included side, then we have two congruent triangles. So now we're going to take a look at our next proof. And that one says that L is the midpoint of WE and that WR is parallel to ED. And we want to prove that two triangles are congruent to each other. I'm just going to highlight those triangles. WRL and EDL. We want to prove that those two triangles are congruent. Okay, the first thing I want you to do before we get started on this proof is to erase something. Cross it out. I don't care what you do with it. It's something that doesn't need to be there. It's this arrow right here. Sorry, that arrow way down here. I just want you to cross this out because we don't need it. Okay, and honestly, I'm going to write it with white just so it's gone automatically, just so you won't even see it. Cross it out. We don't need it. Okay, so let's go ahead and get started. I apologize for that. So what are we trying to figure out here? It told us to prove, and I'm going to write that at the end here, triangle WRL is congruent to triangle EDL. Okay, and what's our, again, since we're looking at angle side angle, we're just going to go ahead and write that under angle side angle. Usually we won't know which congruent shortcut we're looking for. We have to come up with it ourselves. Angle side angle. Okay, but let's look at our givens. Our first given is that L is the midpoint of WE. Okay, and that was our first given. So we write given. Let's go ahead and mark our figure. WE has a midpoint, and it's L. I'm going to go ahead and that tells us that we've got some congruent sides there, and we can move to the next statement and write down, hey, WL is congruent to LE. And how do we know that? I don't know why I wrote it so small. I'm going to erase it and write it again. WL is congruent to LE. And how do we know that? Midpoint theorem. Just using shorthand, you can do it as well, or you can write the whole thing out. Doesn't matter. Midpoint theorem. So if you notice, we've got our first side, or our first piece of information for our proof. Now we've got to find some other things. Now, if you notice down at the bottom here, there's something by itself. And we'll get to that later. The next given, I forgot about our other given. Our last given was that WR is parallel to ED. Okay, and that was our given. Now, if you remember with parallel lines, and I'm going to draw these parallel lines out for you so you can see them. Just extend the lines here. WR, DE, and here's our transversal. Okay, there's our transversal. Let's mark our things parallel. WR, this guy here, is parallel to ED. Remember when we have parallel lines, there are a bunch of angles that are congruent to each other. The ones that we're going to need here for this particular example is W and E. How are those? Those are alternate interior angles. Okay, if you want to, move it over or move your paper around just so you can see it, but those are alternate interior angles. So I'm going to write down that because this is parallel, this leads us to say that angle W is congruent to angle E. And our reason, like I just said, is alternate interior angles. And if you notice, that's our first angle. Now, what do we have here? We've got a pair of angles, a pair of sides. Now, in order for this to be congruent, we need another pair of angles, okay? We know that, but usually we need to look at our figure and find out. What's the one thing that pops out at you that stands alone? I'm going to go ahead and erase these lines. We don't need those anymore. Remember, and I'll tell you what it is. It's right here in the middle. These are vertical angles. We've got a pair of vertical angles there. So I'm going to write down WLR, angle WLR is congruent to angle ED or ELD. Sorry about that. ELD. What's our reason for that? Vertical angles. There it is. There's our last bit of information that we need. We've got two angles, and the two angles, here, write it. Two angles in the included side, congruent to two angles in the included side. And now we could say that this is correct. Our last congruent shortcut is called angle side. If two angles and the non-included side of one triangle are congruent to the corresponding two angles and a side of a second triangle, then the two triangles are congruent. So now we're looking at two angles and a side that's not included. It's not in between the two angles. And two other angles and a side that's not included. If we have those congruent to each other, then we can say that we've got some congruent triangles. Our last proof of the day is just a little bit different. We've got two pieces of information that are congruent. Okay? ADB is congruent to ACE. EC is congruent to BD. Now, before we wanted to prove that two triangles are congruent. Now, look, we need to prove that two other sets of angles are congruent. So let's get started. Okay, we've got our flow chart here. Let's go ahead and start by putting in what we're trying to prove, which is angle AEC. I wrote that twice. I'm not sure why. AEC is congruent to angle ABD because that's what we are trying to prove from back there. Now, we don't know what the reason is yet, and we'll get to that towards the end. But we do have some givens we need to write in here. Our first given was that angle ADB is congruent to ACE. Okay, that was our first given. Go ahead and write given right under there. Let's mark that in our figure. ADB, go ahead right here, to ACE. Okay, our second given was that EC was congruent to BD. So EC is congruent to BD or DB, doesn't matter how you write it. And that one's our given. So I'm going to actually trace this line out. EC, which is this guy right here, I'm going to make it a little bit thicker. Oops. EC, that entire line is congruent, and I'm going to draw it in a different color, to DB. Okay? I'm going to write that these two guys are congruent to each other. So, what do we have here? We've got a pair of angles, got a pair of sides. The last one we just looked at, the last shortcut, if you remember, I'm going to write it down here, was AS. Okay? Remember, two angles and a side that's not included. Notice that the S is not inside in between the two A's. It's two angles and a side that's not included. So we've got this angle here and this side of this one triangle. I'm going to go ahead and trace this entire triangle out because this is the triangle that we're looking at. Okay? And then if we want to, we can trace this entire triangle out too. I'm just going to do it like this so you could see it. Now you notice those are two different triangles. What's the one angle that they have in common that we could use? Angle A right here. Okay? That angle is in both of those triangles, so it's congruent to itself. I can just write angle A. These are the types of things. Angle A is congruent to angle A. Reflexive property. Anything is congruent to itself. These are the types of things that you're going to have to look at and find just by looking at those figures. Reflexive property. Now, that's enough information. We've got an angle, a side, and that other angle. But remember, it's not included. We've got enough information now to say that those two triangles are congruent to each other. So let's go ahead and write that. We've got a congruent shortcut. Triangle, we've got to be very careful about how we write this. So triangle AEC is congruent to triangle triangle ABD. What's our reason for that? Our congruent shortcut, AAS, angle, side. And because of something that we talked about before, because we have those two congruent triangles, we can now say that we have some corresponding parts that are congruent to each other. So we can now say that remember when we did this in class, AEC, which is right here, is congruent to ABD, the angle. I'm going to mark that angle in a different color if I can find one. Well, let's use pink. We've never used pink before. AEC, this angle there is congruent to ABD, which is this angle there. The reason for that is CP, congruent parts of a triangle. The reason for that is something that we talked about in 4-3 was CPCTC. Remember, congruent parts of congruent triangles are congruent. So these parts of these two, parts of these two congruent triangles are now congruent. I know it's a little screwy, a little confusing, but if you just go through it again, let me erase the parts that you don't need. If I were to ask you to do this on your own, we don't need to show any of that. Or the highlighted part, or any of this, okay? All you need to show me is the statements inside of the bubbles and the reasons under them. So to end this very long lesson, very long video, you've got 4 congruent shortcuts that you see here. We're going to briefly talk about them again in class, but if you have any questions, please do not hesitate to ask myself or Miss Robbins. Remember, you've got 4 congruent shortcuts. You can use those to find congruency between triangles. If you have the time, I know you're really not going to want to, but if you have the time, I would advise you watching this video again. If not, I will see you in class tomorrow.